and graphs. There are three views of a function. Mathematicians should be able to represent relations and functions in three forms, using a rule, a table, and a graph. So for example number 1, we want to make a table and graph the following function, f of x equals negative 3x plus 1. So if I'm going to make a table, I'm going to pick some values for my input, my domain, which would be negative 2, negative 1, 0, 1, and 2. So if those are my domain values, I need to find my range, which would be my outputs. So if I'm using my function, that means I'm going to take all my x values and replace them into my function. So negative 3 times negative 2 plus 1, we end up with a 7. Negative 3 times negative 1 plus 1 is 4. Negative 3 times 0 plus 1 is 1. Negative 3 times 1 plus 1 is a negative 2. And negative 3 times 2 plus 1 is negative 5. So now that I have my table, I can now graph this. So add negative 2, positive 7, negative 1, positive 4, 0, positive 1, 1, negative 2, and 2, negative 5. So there can be continuous data as well as discrete data. So we are talking about continuous data when we're looking at temperature, length, weight, and then we use a solid line to graph that. If we're dealing with discrete data, that's when we're counting items. So for instance, if we're counting the number of people, the number of cars, then you use only specific possible points. You do not connect with a solid line. So let's take a look at example 2. We first have to determine whether the following situations are continuous or discrete, and then we create a function, a table, and a graph. So let's first look at this. Suppose your group wants to produce and sell CDs. It costs $150 to produce a master and $3 per CD to produce. Create and graph a function to show this relationship. Well, the type, since we're talking about CDs, we're counting the number of CDs. That means we're dealing with a discrete data. So this is discrete, which means we're only going to be using specific points. So if we find a rule, so let's find our function rule. We are paying $3 for every CD we produce, but we also have to pay that $250 to get our master copy. So if I'm going to create my table using my function, if I start this process but don't make any CDs, 3 times 0 plus 250 means I am still paying $250 for my master copy. If I'm producing 2 CDs, 3 times 2 plus 250 is 256. If I'm going to produce 4 CDs, 3 times 4 plus 250 is 262. If I'm going to produce 6 CDs, 3 times 6 plus 250 is 268. And then if I produce 8 CDs, 3 times 8 plus 250 is 274. So if I want to create a table to show how this represents, the number of CDs is my independent variable, and how much it will cost me is my dependent. So independent, dependent. My independent comes from my x value, so the number of CDs I'm producing. So I can produce 0 CDs, but then I can also produce more than that. So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's my x value axis and my y. So with my y, I'm actually, in order to do this, my smallest amount I'm paying is $250. So I'm going to start here at 250 However, I don't want to go up by 250 each time because then there'd be 500 and that's not going to work. So what I'm going to do is I'm going to do like a little page break there to show that I'm shrinking this down. So I'm not just going from 0 to 250. I'm going to actually be going up by 5s. So 255, 260, 265, 270, 275, 280, 285, 290. So again, this page break is not showing that I'm going from 0 to 250. There's things between 0 and 250. I just shrunk it down and I'm actually going up by 5s. So when I go to plot this, if I don't produce any CDs but I make a master copy, it's going to cost me $250. For 2 CDs, it's going to be $256. For 4 CDs, it's $262. For 6 CDs, $268. And for 8 CDs, $274. And like we said, it was discrete, so that means we only used our possible points and we're not going to connect. So example 3, we have an automatic photo booth and that charges $3 for each set of photos. We want to create and graph a function to show this relationship. So let's first talk about the type. So if I'm talking about sheets of photos, I'm counting how many sheets of photos I have. So this is going to be discrete. The rule, so my function, is I'm being charged $3 for each sheet, and that is it. So my function is 3x. So if I'm going to create my table, I could get 0 sheets, which would cost me $0. If I bought 1 sheet, 3 times 1 is 3. If I bought 2 sheets, 3 times 2 is 6. If I bought 3 sheets, 3 times 3 is 9. And if I bought 4 sheets, it will cost me $12 because 3 times 4 is 12. So I want to create a graph then from this data. So my independent would be the sheets of photos, how many sheets we bought, and then my my dependent then is going to be how much it cost me. So we said we could go anywhere from 0 and we chose up to 4, so I'm going to actually go by halves. So 1 and a half, 2, 2 and a half, 3, 3 and a half, 4, 4 and a half, 5. So to get my y axis now, which is my cost, I have 0, and I'm going up to 12, 1, 2, 10. So I'm going to go up by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18. So I could purchase 0 sheets of photos and it will cost me $0. I could buy 1, excuse me, and it will cost me $3. I could buy 2 sheets and it will cost me $6. 3 sheets will cost me $9. And 4 sheets will cost me $12. And once again, since it's discrete, we're just counting, we just use our specific points. Our 4th example, a person weight on the moon is 1/6 of the weight on the Earth. We want to create a graph, a function that shows the relationship. So the type of this, since we are talking about weight, we are doing a continuous set of data. So we are going to be connecting this with a line. Our rule, our function, is whatever our weight is on Earth, if we multiply it by 1/6, we'll get our weight on the moon. So I picked some values. If someone weighed 100 pounds on Earth, they would weigh 16.7 pounds on the moon. If they weighed 140 pounds on the Earth, they would weigh 23.3 pounds on the moon. 180 would then be 30 pounds. 220 pounds would be 36.7, and 260 pounds would be 43.3, and that's all coming by doing 1/6 times by 100. 1/6 times by 140, 1/6 times by 180. So now that we have this, let's create our graph. So my independent is going to be my weight on Earth, and that's by pounds. And then my dependent is going to be my weight on the moon, also in pounds. So my lowest X value for my independent is 100. So I'm going to do another page break and say that this is 100, and then I'm actually going to go up by 20s. So 100, 120, 140, 160, 180, 200, 220, 240, 260, 280. So then for my dependent, my Y's, my lowest one I have is 16.7. I'm going up to 43.3. So I'm actually just going to go up by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So I'm going to graph this. So 100 pounds on Earth, 16.7. 140 pounds is 23.3. 180 is 30 pounds. 220 is 36.7. And 260 is 43.3. Since this is continuous, we are going to connect them with a solid line to show that.